Here's an experiment you can run right now without leaving your couch. Picture a strong leader in your head. Just the first image that comes to mind. Don't overthink it. There's a decent chance that person you pictured was tall, broad-shouldered, physically larger than average, and if you did picture someone like that, congratulations. You've just demonstrated in about 2 seconds a psychological bias that has apparently been running in the human brain for an extraordinarily long time, possibly stretching all the way back before our species had language, before agriculture, before cities, before anything we'd recognize as civilization. We associate size with capability, with dominance, with safety, with being chosen to lead, to mate with, to follow into battle. Modern studies on perceived leadership and height keep finding the same uncomfortable little pattern over and over. Taller candidates get hired more, taller politicians win more often, and entire corporate boardrooms full of supposedly rational decision makers keep accidentally selecting for stature without ever consciously deciding to do so. But here's the question that's actually interesting, the one that goes well beyond modern office politics and dating apps. Did size actually matter to ancient humans in any way that mattered biologically? Not just psychologically, not just as a vague impression, but in the cold, hard currency that evolution actually deals in: survival and reproduction. Did being bigger genuinely help our ancestors stay alive? Did it help them find mates? Did the climate they lived in change how big they grew? And why, after hundreds of thousands of years of fluctuation, did the invention of farming suddenly make an entire species shrink, in some cases for thousands of years before anyone got that lost height back? The answer involves freezing temperatures, predator deterrence, obstetric catastrophe, hunting efficiency at long distances, a surprisingly recent and surprisingly dramatic height crash that has nothing to do with genetics at all, and a body that, it turns out, was never trying to get simply bigger. It was trying to solve a dozen different problems at once, and those problems didn't always agree with each other. Let's start with the most basic fact, the one that should immediately complicate any simple bigger is always better story. Human body size has not steadily increased throughout our evolutionary history in some smooth upward climb toward modern stature. It's been a chaotic, fluctuating, often contradictory process, sometimes growing, sometimes shrinking, sometimes doing both at completely different speeds, sometimes doing neither for what amounts to an evolutionary eternity. A massive 2017 study analyzing 311 hominin fossil specimens spanning 4.4 million years of human evolutionary history found something genuinely surprising. Height and body mass didn't evolve together in lockstep the way you might assume, marching upward arm in arm toward modern human proportions. Instead, researchers found what they called a pulse and stasis pattern, sudden bursts of change in one dimension, followed by long stretches where almost nothing happened at all, and crucially, height and weight didn't always move together during those bursts. At one striking point in our evolutionary history, around 1.5 million years ago, our ancestors got measurably taller, roughly 10 centimeters taller. But their body mass didn't catch up to match that new height for hundreds of thousands of years afterward. Imagine an entire ancestral population walking around lean and gangly, tall but underweight relative to their height, for an evolutionary eye blink that nonetheless lasted longer than our entire species, Homo sapiens, has existed on this planet. Evolution, it turns out, doesn't build a body all at once, with a tidy blueprint executed in order. It assembles it in pieces on its own bizarre and uneven schedule, sometimes leaving a population stuck halfway through a renovation for 250,000 years. This matters because it tells you immediately that body size wasn't some single, simple trait, that evolution just kept cranking upward because bigger is unambiguously better. If that were true, we'd expect a smooth, steady increase over millions of years, height and weight rising together in a clean diagonal line on a graph. Instead, we get this lurching, stop and start, sometimes reversing pattern, which is exactly what you'd expect if body size were responding to multiple different pressures simultaneously, sometimes pulling in the same direction, and sometimes actively fighting each other for control of the same skeleton. So what were those pressures? Let's start with the one that's almost embarrassingly intuitive once you hear it explained: temperature. There's a long-standing biological principle called Bergmann's rule, first proposed by German biologist Carl Bergmann back in 1847, which observes that among related species, and to some extent within a single species spread across different climates, individuals living in colder environments tend to be larger bodied than individuals living in hot environments. The physics behind this is straightforward enough that you can work it out yourself with a simple thought experiment. A larger body has a smaller surface area relative to its overall volume, the same reason a large pot of soup stays warm longer than a small cup of the same soup. Less relative surface area means less relative area through which body heat can escape into a cold environment. So in freezing conditions, being bigger is thermally efficient. You generate heat with your volume and lose it through your surface, and a bigger body has comparatively less surface to lose heat through relative to how much heat it's producing. In hot, humid climates, the exact opposite logic applies. A smaller body, or a body with proportionally longer limbs and more surface area relative to its mass, sheds heat far more effectively, which is a genuine survival advantage when overheating, not freezing, is the dominant threat. There is real evidence consistent with this pattern across actual human populations, both ancient and modern. Researchers studying human stature across different latitudes have consistently found that populations from lower, equatorial, tropical latitudes tend to be shorter on average, while populations from higher, colder, temperate latitudes tend to be taller. Pygmy populations living in dense, humid tropical forests are a frequently cited example here. Their characteristically short stature, combined with relatively long limbs, is consistent with exactly the kind of heat-dissipating body shape Bergmann's rule predicts would be advantageous in that specific equatorial, high-humidity environment, where the body desperately needs to shed heat rather than retain it. Meanwhile, populations historically adapted to colder, higher latitude regions tend to show the opposite pattern: bulkier, taller frames with shorter relative limb length, conserving heat more effectively against environments where staying warm, not staying cool, was the constant challenge. It's worth being honest, though, that this isn't a clean, universally accepted law of nature, and treating it as a settled iron rule would oversimplify the science considerably. Some researchers have pushed back hard on how cleanly Bergmann's rule applies to the genus Homo specifically, pointing out that human body size is influenced by such a tangled, overlapping web of factors: diet, disease burden, genetics, cultural practices, nutrition during childhood development, that isolating temperature as the single dominant driver is genuinely difficult to prove rigorously. Some critics argue the supposed pattern is closer to what scientists sometimes call a just-so story, a tidy explanation that sounds intuitively satisfying after the fact, but hasn't been demonstrated with the kind of rigorous causal evidence that would let you call it a true law of biology rather than a loose correlation people noticed and then explained backward. The honest scientific picture is considerably messier than a single elegant rule. But the broad correlation between climate and stature across human populations observed again and again across different continents and different independent research teams over more than a century of study is hard to wave away entirely, even with all those legitimate caveats stacked on top of it. Now let's talk about something that affected ancient humans far more directly and far more brutally on a day-to-day basis than ambient temperature ever did: hunting and predator deterrence. For the overwhelming majority of human evolutionary history, our ancestors lived as hunter-gatherers, and their relationship to body size during that period is genuinely fascinating precisely because it cuts in two completely opposite directions depending on what specific survival task you happen to be optimizing for at any given moment. On one hand, size mattered enormously for confrontation, for the simple, brutal fact of being physically harder to harm. A larger, more physically imposing human was simply harder to kill. Whether the threat in question was a predator sizing up an easy meal on the savannah, or another group of humans during a violent dispute over territory, water access, or scarce resources, which, unfortunately, appears to have been a very real and recurring feature of ancestral human life rather than some peaceful prehistoric myth. Bigger bodies, more muscle mass, more raw physical strength These things mattered enormously when violence or predation was a live and immediate possibility, which in the ancestral environment it frequently and unpredictably was. A larger adult body is also generally a strong signal of resource access during childhood development. If you grew big and strong, it likely meant you had reliable access to enough food and managed to avoid enough crippling childhood disease to actually reach that size, which is itself a kind of honest, hard to fake advertisement of underlying genetic quality and circumstantial good fortune. It's the ancestral equivalent of a well maintained, expensive car parked in the driveway. Not proof of anything directly, but a costly signal that's difficult to produce by accident if your underlying resources or genetics weren't already solid. But on the other hand, and this is the part that tends to genuinely surprise people the first time they hear it, size could be a real liability for certain critical hunting strategies, particularly the long-distance pursuit hunting that many anthropologists believe was central to how early humans obtained meat for an enormous stretch of our evolutionary history, well before more sophisticated projectile weapons existed to make hunting less of an endurance contest. Researchers studying the relationship between body size and late Paleolithic hunting technology have noted that a large human body might actually be less favorable than a smaller, leaner one when chasing large mammals. Over long distances was the primary hunting method available, because endurance running efficiency depends heavily on a leaner build with less mass to haul across miles of unforgiving terrain in punishing heat. Among certain short-statured hunter-gatherer populations studied by anthropologists in the modern era, like the Juhonsi people of the Kalahari Desert, researchers have found that the most successful hunters actually tend to have higher fertility, more offspring surviving to adulthood, than their less successful counterparts. But successful in this very specific context doesn't necessarily mean biggest or most physically imposing. It means most effective at the specific physical task the local environment demanded, and in a hot climate built around long-distance persistence hunting, that task often favored a leaner, smaller, more heat-tolerant build over sheer muscular bulk. This is the genuinely interesting tension sitting at the heart of the whole "did size matter" question. It depended enormously on exactly what you were optimizing for at any given moment, and different environments, different hunting strategies, and different climates pulled the optimal body size in completely different directions simultaneously. There was no single universal answer that applied to every ancestral human population everywhere. Evolution doesn't deal in universal answers handed down from on high. It deals in localized trade-offs, calibrated environment by environment, generation by generation, with the body constantly being pulled in whatever direction local conditions demanded most urgently. Then there's the question of size and reproduction, which gets considerably more complicated and considerably more consequential, particularly when you look at how it played out differently for males and females. Human males and females show what biologists call sexual dimorphism in body size. On average, males tend to be taller and more heavily muscled than females across virtually every human population studied, although the actual degree of this difference has shifted measurably over evolutionary time in ways that are themselves genuinely revealing about what forces were shaping each sex differently. A study analyzing dental and skeletal data across great apes alongside 10 different hominid samples found a measurable, documented decline in sexual dimorphism in body size over roughly the last 3 million years of our evolutionary lineage. In plainer terms, the size gap between ancestral males and females was, by most available measures, considerably larger in our distant evolutionary past than it is in modern humans today. And that gap has been gradually, steadily narrowing across an enormous span of evolutionary time. Interestingly, there's also a documented contrast in the modern era where contemporary agricultural societies have tended to show greater sexual dimorphism in height than contemporary hunter-gatherer societies do, suggesting that the social structure of a population, how labor gets divided between the sexes, how resources and food get distributed within a household, how status gets allocated and along what lines, can meaningfully affect how much bigger males end up growing compared to females within that specific group, layered directly on top of whatever the underlying genetics happen to be doing in the background. Why would this gap have been larger in the deep evolutionary past and then shrunk over time as our lineage progressed? Researchers studying this question have proposed that human sexual dimorphism in height may result from a genuine evolutionary trade-off between size-related mortality risk on one hand and size-related complications in childbirth and fertility on the other hand, with these two competing pressures pulling female body size in particular toward a very specific, narrow compromise. Larger female body size carries certain survival advantages in terms of physical resilience and resource buffering during lean periods. But the human birth canal is structurally constrained by the demands of efficient bipedal walking in ways that create a very real and genuinely dangerous tension with successfully delivering large-headed, increasingly large-brained infants. This is sometimes referred to by anthropologists as the obstetric dilemma. Human babies are born in a relatively underdeveloped, helpless state compared to the infants of other primates, precisely because waiting any longer inside the womb to develop further would make the act of birth itself catastrophically more dangerous for the mother, given the specific geometry that bipedal walking forces onto the human pelvis. Female body size and overall body proportions appear to have been calibrated by selection pressures that include this dilemma directly and centrally in a way that simply doesn't apply with anything like the same force or urgency to male bodies, which helps explain why male and female size evolved along somewhat divergent trajectories over time rather than simply scaling up or down together as a single, unified biological unit moving in perfect lockstep. And then comes the plot twist that really should not have happened on paper if civilization equals unambiguous progress were a simple and reliable rule of history. Agriculture made humans shorter. Significantly, measurably, consistently, and for an extended period of time spanning thousands of years before anyone managed to claw that lost height back. This is one of the more genuinely counterintuitive findings in the entire archaeology of human body size, and it has been documented repeatedly across multiple independent lines of skeletal evidence from different research teams working in different regions. Skeletal studies of ancient European populations have found that humans living before roughly 16,000 BC, meaning late Paleolithic hunter-gatherers, well before farming had been invented anywhere, averaged around 179 centimeters in height for males, which is genuinely tall by almost any historical standard you could compare it against, comparable to or even exceeding the average height of modern populations in many wealthy, well-nourished countries today. By the period between 8,000 and 6,600 BC, as agriculture began spreading and taking hold across various regions, average male height had dropped to around 166 centimeters, a substantial, measurable decline within a relatively compressed span of human history. By the Neolithic period, after agriculture had become firmly and widely established as the dominant way of life, average heights had fallen even further still, down to roughly 164 centimeters for males and around 150 centimeters for females. And here's the detail that should genuinely stop you. Human stature in parts of Europe didn't reliably climb back above 170 centimeters until the very end of the 19th century. That means it took many thousands of years and ultimately the arrival of modern nutrition science, public sanitation, and medicine for average height in some regions to simply recover ground that had been lost the moment humans abandoned hunting and gathering for farming. An entire multi-millennium height recession, essentially, hiding in plain sight in the archaeological record. Why would switching to agriculture, supposedly the great civilizational leap forward, the very foundation upon which cities, writing, mathematics, and everything we typically associate with human progress was eventually built, actually make people physically shorter as a population? The leading explanations point toward a cluster of related, mutually reinforcing factors rather than any single clean cause. Early agricultural diets were far less nutritionally diverse than hunter-gatherer diets had been, often relying heavily on a small handful of staple grains rather than the wide, varied diet of wild plants, game animals, fish, nuts, and foraged seasonal foods that had characterized earlier hunter-gatherer subsistence strategies. And that dramatically narrower diet frequently meant significantly lower overall protein and micronutrient intake, specifically during the critical childhood years when skeletal growth and bone development actually happen. Agricultural settlements were also considerably denser and far more sedentary than hunter-gatherer bands had ever needed to be, which meant dramatically greater exposure to infectious disease. since pathogens spread far more easily and persistently in crowded permanent settlements with shared water sources and accumulated waste than among small, highly mobile groups who rarely lingered in one location long enough to build up the same disease burden in the surrounding environment. Chronic childhood infection and inadequate nutrition both independently stunt growth, and early farming societies appear to have delivered a substantial measure of both simultaneously, compared to what had typically come before in the hunter-gatherer way of life. Genetic evidence has even uncovered specific signs of active natural selection for decreased stature in certain Neolithic and Chalcolithic populations in Iberia, suggesting that in some particular regional contexts, smaller body size may have actually become genuinely advantageous under the demands of the new agricultural way of life. Perhaps because smaller bodies simply required fewer total calories to maintain in a world where calories had suddenly, paradoxically, become less reliably available on a year-round basis despite the existence of farms due to crop failures, seasonal scarcity, and a far less varied nutritional safety net than foraging had previously provided. A more recent study from researchers at the University of Pennsylvania, examining Neolithic skeletal remains roughly 6,000 to 8,000 years old, found something additionally interesting layered on top of all of this. Differences in stature between males and females during this specific period couldn't be fully explained by genetics or diet alone, and appeared to reflect genuine cultural factors as well, meaning how a particular society chose to distribute food, labor, and resources between the sexes may have directly and measurably shaped how tall its members actually grew up to be, on top of whatever pure biology was doing quietly in the background. Height, in other words, wasn't purely a passive product of genes responding mechanically to climate or hunting strategy. It was also, in genuinely measurable and documentable ways, a product of culture, social organization, and the specific choices a society made about who got fed how much and when. So, did size matter to ancient humans? The honest answer is enormously, in ways that pulled in several entirely different directions simultaneously and were never resolved into one clean, single, universally applicable, bigger is always better, or smaller is always better rule that governed every population everywhere across the whole of human prehistory. Size mattered for surviving cold climates, where a bulkier frame conserved precious metabolic heat that could otherwise leak away into a freezing environment. It mattered equally for surviving hot, humid environments, where a leaner frame with proportionally more surface area helped shed dangerous excess heat instead. It mattered for intimidating rivals, predators, and hostile neighboring groups, where raw physical presence could genuinely be the difference between a confrontation peacefully avoided and one that escalated into real violence with real consequences. It mattered for the brutal, unforgiving mathematics of long-distance pursuit hunting, where a smaller, leaner, more thermally efficient body could reliably outlast a larger one across miles of unforgiving open terrain under a punishing sun. It mattered profoundly and specifically for human reproduction, shaping male and female bodies along genuinely divergent evolutionary paths because of the extraordinarily delicate anatomical tightrope our entire species has had to walk between efficient bipedal movement on one hand and successfully giving birth to large-brained, increasingly cognitively complex infants on the other. And it mattered, quite devastatingly as it turned out, when humans fundamentally changed how they obtained their food. When farming finally arrived on the scene, and one largely unintended consequence was that entire populations grew up measurably shorter than their hunting and gathering ancestors had been for countless prior generations, sometimes for literally thousands of years before that lost height was ever fully clawed back through better nutrition and modern medicine. There was never a single, tidy ancestral answer to whether bigger was simply better. There were dozens of overlapping, frequently contradictory answers, each one carefully calibrated to a specific climate, a specific predator threat, a specific hunting method, a specific and precarious stage of human reproduction, or a specific way that a given society chose to organize and distribute its food supply. Evolution doesn't optimize towards some single universal ideal body that works equally well everywhere. It optimizes messily, incompletely, and often contradictorily for whatever specific trade-off happens to be most urgently pressing in one particular place, for one particular population at one particular moment in time. Which means the next time you catch yourself instinctively picturing a tall, broad-shouldered figure the moment someone says the words strong leader, you're not actually tapping into some timeless, universal truth about inherent human excellence or biological superiority. You're channeling one very specific evolutionary thread pulled out of an enormously tangled rope of competing ancestral pressures. A thread genuinely shaped by predator deterrence and physical confrontation, sure, but one that conveniently ignores the lean, wiry persistence hunter who could run an antelope into total physical collapse over 6 brutal hours in the open midday heat, or the smaller-bodied forager who simply needed dramatically fewer calories to comfortably survive a long, lean season when food was scarce and every saved calorie genuinely counted towards staying alive until the next harvest of wild plants came in. Size mattered enormously to ancient humans. It just never, not even once across our entire evolutionary history, mattered in only one single direction.